So for this question, let me ask a question. Are the elements in the given array unique? Yes? Okay, so the input is an integer array which is already sorted in ascending order, and the output is an integer which represents the index of the target if it does exist in the given array, or -1 if it doesn't. So, and what if we're given null or empty array? Can I assume that we can just return -1 as well? Yes? Okay. Well, for this question, of course, we can examine every single element in the array to see if it is equal to the target or not. But then that will cost us big O of n time. And in that case, we're not taking advantage of the fact that this array is already sorted. So we can just use binary search to solve this in big O of log n time with constant space. And the general idea is that for each array and all its subarrays, we always check the middle element and compare the middle element value to the target. If the middle element value is equal to the target, then we have found our answer and we can just return the middle element index as our result because we find it. But if the middle element's value is smaller than our target, then it means that all the elements to the left of the middle element, including itself, are smaller than the target. So we can discard the left half of the current array and keep looking for our result in the right half. Likewise, if the middle element value is larger than the target, then it means that all the elements to the right that are right to our middle element are all bigger than our target. And then in this case, we can just discard the right half of the current array and keep looking for our result in the left half. So, and then we keep doing this until we have examined all the elements in the given array. After we're done this, if we still haven't find any result that is equal to the target, then we can say that this target does not exist in the given array. And so, for example, if our given array is like this, 3, 5, 9, 12, and let's say our target is 10, then we can have two pointers to help us define the search space, the left pointer and the right pointer. The left pointer, and then so together they can define a closed interval that all the elements between in this closed interval, including the boundaries, are the elements that is going to be examined, and all the elements that's outside of this closed interval are the elements that we've already examined and discarded because they cannot be our target. They cannot be our answer. Then let's try this on some example. So if at first our left is here and our right pointer is here, then the middle point would be right here. So we compare the middle element value to the target, and as we can see, it's smaller than the target, then it means that all the elements to its left are smaller than our target, so we can just discard the left half and move our left pointer to here. Here we can just pass the middle point because it's impossible to be our result. And now we're here, and our middle element would be here. It would be 9. And then again, we compare its value to our target, and it's still smaller. So again, we move our left pointer to here to discard the whole left half. And now the middle element will be here. And as we can see, now the middle element value is larger than our target. Alright, so we can discard the current, the right half of the current search space now, and we're gonna move our right pointer to here, to one index less than the middle point. And at this point, we can see we've already examined all the elements in the array, and we still haven't found any result. So we can say our answer will be -1. Yeah, and then for example, if this is, for example, if our array only has one element, let's see if it's still equal to 10, and at first left will be here, and right will be, and right will be here, and M will be here. And we compare middle element value with target, and we can see it's smaller than the target. And so we're gonna move our left pointer to the position that's to the elements that's right next, that is to the right of the middle point. So we're gonna move it by here, and we can see we've already examined all the elements, and we're just gonna return -1. So I think it works fine. And can I start coding? Okay, so we're gonna have a class called solution and write our functions inside. So the input will be an integer, and we can just call this method binary search, and we are given a integer array and a target, which is also an integer. So first we can do some sanity check. To see if our input is valid. So if nums is no, or it's an empty array, then we can just return -1. And then we can define two variables. One is the left pointer. We will put it at the first element. We will point it, the left pointer will point to the first element at first, and the right pointer will point to the last element at first, and then we're gonna have a while loop until so, and then the left pointer is keep moving right while the right pointer keep moving left until they are in the same position and next to each other. We can jump out of the loop. So the middle point would be left minus. We can just write it in this way. So to avoid the integer overflow. And so right now and then we compare its value to the target. If the value is equal to the target, then we find our result and we can just return its index. Else, if the target is smaller than the current value, then we can discard the right tab, and by moving our right pointer to the one that's left to our middle element. And in the end, if it's larger than our target, if the target is larger than our current value, then we're gonna discard the left half by moving the left pointer to the one that's next to the middle point. And then we just keep doing this until we are out of the loop. We need a few more. All right, and then when we are out of the loop, then we know the target does not exist in the view, and we can just return -1. Well, and let me check if there is any error. Times 1 left is 0, right? Left -1, return it, all right. Yeah, I guess it's fine. And then let me try some tests on this code. So for example, this is our input. Then we can see that now left equals to 0 and right equals to 5. 2, 3, 6, yes, 5. And then while yes, here mid will be 2. And here the current value will be 3. So target is larger than the current value, so we should increase the left pointer to mid plus 1, which is 3. And left is still smaller than or equal to right, so we go into the loop and mid will become 4 here, and the current value will be 9, and here the target will still be larger than the current value, so again we will increase left to mid plus 1, which is 5, and left is still smaller than or equal to right, so we will go into the loop, and then so here mid will become 5, and the current value will be 12. So now the target is smaller than the current value, and so we're going to decrease right to mid minus 1, which is 4. And now we jump out of the loop, and we didn't return anything, so we're just return minus 1. And let's see if there's only one element in the given array, then here it will be 0, and left will be 0, right will be 0 as well, and they're equal, so mid will be 0, and the middle element value will be 12, and target is larger than our current value, so we will increase left pointer to mid plus 1, which is 1, so left will become 1, and here left is no longer smaller than or equal to right, so we jump out of the loop and return minus 1. So that'll be it. Thank you.